All right. Welcome to our English medium combined math program. Uh, so, when you follow a certain course in English medium, you will be definitely in an advantageous position or favorable position, uh, in particular for two reasons. One is when you enter a university, you will be in a favorable position in understanding the lectures delivered in English medium. Second is that if you want to apply or if you want to get or secure a berth in a top-notch university abroad, you can easily get a chance. I mean, I don't say easily, but you will be in a favorable position, in a good position to get a scholarship if you follow English medium, because then you can have a good score in SET. SET in certain cases, SET is a must. So you can perform better in SET exam. I mean, students' aptitude test. That's why we abbreviate it as. I mean, that's what we abbreviate as SET. You can score better in such exams, then you can easily secure a berth in a top-notch university. When it comes to our combined math program, you know, before I have to tell you something about the first topic. It's in fact not in the syllabus, but some hours are allocated to cover basic algebra. So I want to tell you something about the background of it. Before 1980, we started A levels from where we have stopped O levels. So basically, there's no gap. There's no gap at all. However, in 1980, our O-level mathematics subject was made compulsory. Once it was made compulsory, if you don't get through the subject, you cannot follow A levels. Therefore, it's a kind of a risk. Therefore, what they did was to increase the passing rate. Earlier the pass rate was about 30%. So, to increase this, they have kind of watered down the quality of the paper. I mean, you should do it, right? Otherwise, a lot of people cannot get through. Therefore, as a remedy, certain problems are watered down. Therefore, you don't have to go through a tedious process to get through O-level mathematics, like it was, right? Therefore, it created a certain gap. Like when it comes to algebra, the practice you need to do all the problems in O level is not a big deal. I mean, you can spend few hours and do those problems well. Because of that, it created a certain gap. The practice-wise, the time spent in algebra, right? The time spent in algebra is less significant. I would say it like that. So because of that, there was a gap created. Now, when we start A levels with a gap, students find it little hard to cope up with the problems in the initial stage. So when we go deeper and deeper, they will find it little hard. Therefore, in 2019, for the first time, they suggested to fill this gap, right? So that's why this basic algebra is there. We have to go through some simple stuff, right? But we need to spend some time on those things just to fill that gap, right? Like factors, like difference between two squares, difference between two cubes, or sum of two cubes, like kind of expansions, binomial expansions, trinomial expansions, and stuff like that. Not very hard stuff, but we need to give you some more exposure. because the exposure you get in your O levels is not sufficient. That's the basic idea of it, right? I mean, we cannot say that the students who come to the A levels are not are weak or they don't know algebra. They know algebra, but the time they spend in spent in that particular subject is little less, or I would say less significant. Therefore, as a remedial action, we have to go through basic algebra. All right. So we'll start basic algebra. So the first topic, factoring or factorizing or factorization. In US, like in US English, like you can say factoring. That would be enough. Or factoring, right? So first one, the difference between two squares. I would say factors would be good enough, right? I will delete it 10 factors. That would be enough. Okay. If you have, say, A and B are two real numbers or some algebraic quantities, you can factor it like this. This is the simplest form, simplest one. Let's go through the proof. Proof is also very simple. We can start from the right hand side and simplify it. We can eliminate brackets and then we can get this answer. So we'll consider A minus B times A plus B. Now, if you multiply them out, A times A squared, A times B, AB, then minus B times A, minus AB, minus B times B, minus B squared. So this is plus, this is minus. These two will go away, leaving A squared minus B squared as the answer. So this is equal to this. Therefore, A minus B times A plus B, I have to start from the other side, right? A squared minus B squared is equal to A minus B times A plus B. Now we'll go through some examples. All right. We'll see how we factor them. Let's take the first one. Like when we were in our O levels, probably it's expected to do it like this: x squared minus 5 squared, so that it will go hand in hand with a squared minus b squared. However, in this case, now at this stage we don't have to waste our time. Now you can write this as 5 squared, right? You can take, you can I mean, without writing it, you can assume that it's 5 squared. So it's like a squared minus b squared. You can straight away write it like a minus b or x minus 5 times x plus 5. Exactly like this. Difference times the sum. Again, the second is the same. Simple enough. Because 49 is 7 squared. So you can assume that it is x squared, I mean, you can take it as x squared minus 7 squared. You don't have to write it as a step like, I mean, you don't have to insert a step, but you can take it as 7 squared. So you can write it as x minus 7, x plus 7. Third. Now, we have 3x squared minus 12. These are very simple, huh? Like, these are like all of them, at least most of them are all your problems. But we need to give you some exposure in that, some more exposure. If you take this one, none of them is a square. However, there's a common factor. In fact, like if you want to factorize something, the first thing, it's kind of a rule of thumb. The first thing you need to do is to identify the common factors and pull them out. Here 3 is a common factor. You will end up with x squared minus 4. Now this is the difference between two squares. So you can factor this. This is x squared minus 2 squared, therefore x minus 2 times x plus 2. Now we will go for this. 4x squared minus 100. 4x squared minus 100. Both of them are squares, but don't make this mistake. Don't take, okay. Now, even though both of them are squares, don't straight away factor them. Pull out the common factor. There's a common factor. 4 is a common factor. Pull out 4. You get x squared minus 25. 25 is 5 squared. So you can write the answer like this. X minus 5, x plus 5. Then we can move to this. Four x squared minus 25. Now here you better insert a step, because 4x squared is what? Let me recall what it is. Somewhere here or somewhere here. Here. Now okay, if you have 4x squared, it's like this. Take pq, like p squared times q squared. By the rules of indices, you can write it like this. Like you can simply take this as a common power and write pq in the brackets. You can do it for a division as well. No matter what the power you have, even with 3, with 10, with n, you can do the same thing. But if you have an addition, you cannot do it. For a product or division, you can do it like that. Now, this is what we are going to do. One thing. When you have something like this, okay, you can write it in this way. So, when you have 4x squared, this is in fact 2 squared times x squared. So, using this, you can write it as 2x quantity squared, like this. But you don't have to show this intermediate step, it's not necessary. So, you can write it like this. 2x quantity squared minus this is 5. Since you insert a step, you can write it like that. But it's not a must. If you write the final answer straight away, that's accepted. But since I am working on the board, I will insert more steps. So this is 2x minus 5, the first factor. The second factor is 2x plus 5. 6, this one. X to the power 4. For the first time, we encountered something like this. Now, this is the square of x squared. You know, when you have, like when you take a power of something like that, we have to multiply these two. We don't add them, we have to multiply these two. So 4, you get 4 as 2 times 2. Since you insert that step, you can write it like this. So the roots are x squared and 4. So in here you get x squared minus 4, the first factor. Second factor is x squared plus 4. I mean, you don't have to go through this. You can straight away write it like that. It doesn't matter. But I just want to show you how it happens. Now, after this, most of you, I don't say most of you, but most students stop the answer there, which is row. So, the factoring is done partially. Therefore, you have to factor this again, because this is again a difference between two squares. You have to factor it. This 2 squared, you don't write it as 2 squared, it's too simple. So, you factor that. You have x squared plus 4 as the last factor. So, you can break this into 2, x minus 2 times x plus 2. Right? Now, we are done with that. We will go through 7. None of them is a square. However, there is a common factor, 3. So, you pull out 3, you get x to the power 4 minus, you have divided this by 3. So, it is 81. This is square. We know how to do it. Now, we don't have to insert that. This is square of x squared. This is the square of 9. So, you can factor it like this. X squared minus 9, x squared plus 9. Again, this is a difference between two squares. So, it is x minus 3, x plus 3. So, this stays as the last factor. Right? Eight. This one. Both of them are squares, but you better identify this as the square of 2x. This 3 squared times 9 squared means 3y quantity squared. But this insertion of this step is not a must. You can skip that if you want to. So, you get 2x minus 3y, and the other factor is 2x plus 3y. Nine. This one. X to the power 4 times y to the power 4 minus this. Both of them are squares. Don't go too fast. Don't try to factor it at once. You pull out the factor, common factor. Y to the power 4 is common. That leaves you with x to the power 4 minus 16. Now, again, this is a difference between two squares. This is the square of x squared. This is the square of 4. But you don't have to explicitly write it like that. You can straightaway factor it like this. X squared minus 4 times x squared plus 4. After that, now this again a difference between two squares. So you can write it as x minus 2 times x plus 2 9. Now we'll take up problem 10. It's not that difficult. Again, you have to pull out the common factor 4. And you can take it as the square of 2x quantity. So this 2x quantity squared minus 1. 1 is also 1 squared, right? So it's a difference between two squares. So the first factor is 2x minus 1. The second factor is 2x plus 1. Last one. Problem number 11. X to the power 8 minus 1. Both of them are squares. This is the square of x to the power 4. If it's not clear, let me insert this step. You know, by the rules of indices, when you multiply these two, you get 8. Because x to the power 4, in x to the power 4, you have 4 x's. If you multiply it by x to the power 4 again, you get altogether 8 x's. So x to the power 8. Now you can write the first factor, x to the power 4 minus 1. The other factor is x to the power 4 plus 1. Again, this is a difference between two squares. So this is the square of x squared minus 1, x squared plus 1. And you can again factor this because this is a difference between two squares. X minus 1 times x plus 1. This is x squared plus 1. Right? Okay. Let's do some more examples. Because without the exposure, without this exposure, when you deal with certain examples, you will end up with wrong answer. Right? We want to minimize the mistakes made by the students. That's a basic idea. I mean, these are very simple stuff. I mean, they are not difficult. However, if you try to make mistakes when you deal with simple algebraic manipulations, it's a waste. So we need to minimize. We need our students to make minimum number of mistakes. I mean, people make mistakes. That's fine, right? But it shouldn't be the cause for those mistakes shouldn't be the lack of experience or lack of exposure to algebra. Okay. Now we'll take up 3 examples. All right. So these are kind of straightforward. But you have to, the use of parentheses is of paramount importance here, right? So in the first factor, you need to have a difference minus x minus 1. This bracket is important because this minus sign is common to both terms. Therefore, that negative sign is very important. The pair of brackets, that's important. When you add them, probably that's not, the pair of brackets is not that important, but here it's a must. Others will end up with the wrong answer. Now, you can simplify. add similar terms like here subtract 2x minus x is x plus 1 here minus times minus, like when you this minus sign will affect this one, so minus times minus is plus, it will change the sign, so it is plus 1, 1 plus 1 2. Here add similar terms 2x plus x 3x, 7 minus 1 6. Now there is a common factor here, you can pull out 3. You have x plus 2 times x plus 2. Wow. How can it be? Hold on. Now. Here you have x. Yes. 3x, here you get 8. 49 minus 1, 48. Yes. Hold on. Now. If you simplify, you get 4 minus 1, 3. There's something, hold on. This 7, that's why, that's what happens, this 7. 7 plus 1, 8. Now it's correct. Here instead of 7, I have written 1. Now it's fine because here I haven't made a mistake. Now this is correct. Right? Okay. Now we'll take up the second. Now this is kind of straightforward. If you, if you use the parenthesis correctly, this is not a big deal. Here the square root is x squared plus 1 minus x. Don't put x squared because this is the square of x. It should be x. Next one, x squared plus 1 plus x. Here you can write the powers in the descending order, that looks better, right? Therefore, this is x squared minus x plus 1, this x squared plus 6 plus 1. Third one, this. Right. Here you have to use the parentheses very carefully. This is the first factor minus the second factor, second square root. Then first square root minus this. So you will end up with 3x minus 2x is x. Minus 4 minus 1 minus 5. Hold on, this plus 3x plus 2x, 5x, minus 4 plus 1, minus 3. So this we have started from the scratch, very simple stuff, because if you miss very simple stuff, you can go into great heights, because if you want to deal with very difficult problems towards the end, it's meaningless. Therefore, we have to go from the scratch and achieve great heights towards the end. Okay, thank you very much. After this, we have to invoke difference between two cubes and difference sum of two cubes. Okay.